So 1.4 is about observational and experimental studies. So we've talked about lots of different things up to this point. We got on the same page with vocabulary that gets used often in statistics. In 1.3 we talked about different ways to collect data. We talked about different types of sampling activities that a researcher could get involved in. Today we're going to talk about a couple other types of studies. We've talked a little bit about observational studies already. That's when we talked about direct observation. Okay, that is what we're doing with an observational study. And then experiments. Okay, we're going to look at some examples for some medical experiments, and that's something that we see a lot. So let's talk about the definitions. Here's what an observational study is. The researcher observes what's happening and tries to draw conclusions based on those observations. So this is similar to that idea of the, person hiding out in the bathroom watching whether or not people wash their hands, right? They're observing the behavior. The other example I used was somebody sitting up on the corner of that street up there and seeing if we need a stoplight or the stop sign's good enough. So somebody's actually watching, observing. It doesn't have to be necessarily in person. You could do it with a camera and observe people's behavior that way. So it's not necessarily somebody, sitting right in your grill watching what you're doing. It could be from a distance as well. Then, of course, there are experiments. An experimental study. The researcher is going to manipulate one of the variables. Try to determine how the manipulation influences the other variables. Now, I know that's very vague. And in your science classes, in the labs that you've participated in over the years, you have done these things. Okay, now, not necessarily on your own trying to come up with it, right? You've been given some direction about what types of things you have to manipulate, bless you, what types of things you manipulate, and then you record the impact of those manipulations. Okay, so some of the stuff that we're going to talk about today, some of the terms you're familiar with already because you've done it in some of your other classes. So that's, and that just, as an aside, one of the things about, one of the questions that high school students always ask, maybe it's not even high school, maybe it's before, like, when are we ever going to use this? That question, the one that lots of math teachers get all frustrated about. Statistics is one of those subjects within math that has applications in many different fields. And what you'll find out, and for those of you who have older siblings that are already in college or have finished college, they might be majoring in something where, they weren't a math person, they're like, okay, I'm not going to have to do math anymore, woohoo! And then all of a sudden they're in a statistics class. And people are like, what? Why am I having to do statistics? I thought I was done with math because my major field was, I don't know, art or English or, I don't know. You're going to be, we talked about being a doctor in statistics. These have applications, and a lot of it is because of these two ideas here. Every college requires what are called general education requirements, right? And that's like your basics. So you're going to take some English classes, you're going to take some, social sciences, you're going to take some math. Now you can test out of, you're going to take some science, you can test out of some of that stuff. And a lot of times at freshman orientation when you go, that's when you do your testing, and then they place you into a specific course, and they'll determine, okay, you might need remedial math, and you're going to have to take, I don't know, college algebra, for example, and kind of ease your way into some other math courses first. But it depends on the school you go to. It depends on your field of study. And those are things, I know for some of you, it's right around the corner, and those are things you've already started thinking about. For others of you, it's not quite there yet. Those are things that you should also consider before making a decision on where you're going to go to school. Okay, so all those things impact your future success. I know we're getting on a tangent a little bit, but ultimately, statistics, I had friends in college, now granted it's been a long time, but they were business majors. They're like, and then they're taking calculus. They couldn't figure out why you need calculus to be a business major. So there are things like that happen. You go, what? Why? And the colleges require what the colleges require, and either you go along with it or you go to another school. That's how it kind of works. All right, tangent over. So there are two types of variables. So in the experimental studies, we mentioned variables, and the same two types of variables that you worked with in algebra will be in play here. They will have a little bit different meaning, but they are also very similar. First of all is the independent variable. Was that the x or the y in algebra? Yeah, it was the x. Independent variable is the x. The variable being studied by the researcher, another way that they will describe it is the explanatory variable. You know what the next thing's going to be, right? So, just go ahead and start writing it without me putting it up there. Like, use your inferential skills to write down the next type of variable. You know what it is. What is it? Dependent variable. So the dependent variable, the outcome, or also known as the resultant variable, because it's where the results are interpreted, is the dependent variable. So in an experiment, that manipulation of the variable, that's where we're looking at the results. How does this manipulation impact the study? How does it impact the variables in the study? That's where that dependent variable really comes into play. Because ultimately, that manipulation is going to help us determine what direction we need to go in case A. I know it's harder to understand when we don't have an example, but we're going to get there. But that's kind of what's going on here, okay? So in an experimental study, there are two groups. And this is where your science lab experience should help you feel confident about what the groups are, right? Do you remember what the groups are that are involved in an experiment? What's one group? What? The control group. What's the control group? Yeah, you don't mess with them, and you just leave them alone. You make them pretend something's happening to them, right? You tell them they're in the study, and you don't do anything to them. Okay? What's the other group called? Do you remember? No, it is not the test group. The what?
Experimental group.
Experimental group. No, that is not correct. What'd you say? It's the second group. It is called the treatment group. That group is the one, yes, that is being sort of experimented on. That is receiving some type of test where the manipulation is happening. Okay? And in the medical field, they are receiving some type of treatment. Maybe it's a drug. Maybe it's an environmental change. And you've already mentioned the other one, and that is the control group. And that's the one that doesn't receive a specific treatment. Is there anyone unfamiliar with these terms? Treatment group obviously is sort of a maybe different term, but you know what it means. Maybe you've worked with it before, you just maybe didn't know what to call it. Control group. Okay. So let's look at an example. And if you would like to take a picture of this, you may, because it's kind of wordy. And then we'll have you answer those questions. So actually, why don't you take a picture of that, answer those questions, and then we'll come back together and see what you came up with. Vivian, I'd like you to read this in German, please. Can you try? Just for fun? No, I'm kidding. All right, who would like to read it? Besides Ashton, because he is such a good out loud reader. Anthony, go for it.
Pharmaceutical company developed new blood pressure medicine. In order to test the effectiveness of the new medicine, 20 individuals that were known to use an already existing medicine for blood pressure were selected. Half of the individuals continued to use the old medicine, half of the individuals were given the new medicine. Results were reported.
Very good, thank you. Okay, so here's our situation. Is it experimental or observational? Yeah. Or is it? Yeah. It is what? Experimental, right. So we're experimenting on half of the people, they're getting a new medicine. The other people just keep doing the same thing they've been doing. So it is experimental. How many have that? Good. All right. Treatment group and control group. So what's the group that nothing is changing to? People that are taking the old medicine. Nothing's changing for them. So they are which group? Control. So the treatment group is the group that's receiving the new medicine. Okay, so there's a treatment group, the half given the new medicine. In this case, some of you wrote the 10 given the new medicine. That is good division by 2. Half of 20 is 10. Very good. Okay, and the control is the half taking the old medicine. Because nothing's changed for them. They continue to take it. All right, so here's where sometimes it gets a little tricky. The independent variable and the dependent variable, and your wording really matters here. And you need to be specific. And just wandering around looking at some of the things you wrote, you're going to want to adjust what you've written. And I don't want you to replace what you've written. This is something important that I talk about all the time in my classes. Don't get rid of your answer just because you think it's wrong or not entirely correct. Because sometimes it's not entirely correct, doesn't make it wrong. I want you to add to that what I'm going to show you here. Because one of the things, and a lot of you have had me before, one of the things you know about me is that I'm picky. If you mess up one little part, I'm going to take points off. Okay? And so, in the end, I want you to be as absolutely specific as possible. So when I show you the independent and dependent variable, if you weren't as verbose as I would like you to have been, please add that to what you have written down. Don't get rid of what you had written down. Okay? I often think learning from your mistakes is better than just regurgitating. So let's start with the independent variable. Okay, the independent variable is the medicine that was given. Okay. Now, whether that is the new medicine or the old medicine, each group receives medicine. So here's why that's important. It's not just the new medicine, because everybody in the experiment receives medicine. Okay? Although the treatment is the new medicine, the other 10 people are still getting medicine. Just so happens that they're not getting the new medicine because ultimately it's possible that the old medicine will still work better than the new medicine. So medicine is given. And oftentimes in an experiment, they use what's called, what do they call the sugar pills? The sort of fake medicine, placebos, okay? So they'll give a group something that they think is medicine, when in reality they're not getting anything. Okay? So that's the independent variable. Now, what is affected by the medicine? So that's where the dependent variable comes in. The medicine affects what? The blood pressure. So the dependent variable has to do with the blood pressure results. So which one affects the other? That's when we're looking at independent and dependent variable, we're saying, okay, what are we injecting or infusing into the experiment? And what are the results based off of those variables? And again, think about it this way. There's an experiment for a reason. We're trying to decide, to determine, the researcher is, what kind of impact the treatment has. Okay. Even though the group of people aren't receiving a new treatment, half of them aren't receiving a new treatment, they're still receiving a treatment. Okay, it just so happens that that treatment is the same as what they were doing before they showed up to the experiment. Okay? So that level of distinction is important. Any questions about any of that? Yes, sir.
Read the restaurant.
In a minute. That is not a question about this.